Welcome to Let's Program Episode 7, the continuation of me screwing up. Right now what we're doing is basically the most useful thing that we're going to be doing all video, which is taking out the old object updating system and replacing it with one where instead of objects being altered in the list as each time they are updated, each object can only modify itself and only do it once. However, it can mark other objects to be added and removed from the object list, which happens all at once at the beginning of each tick. There's a reason for this, and that is that altering an object in a list multiple times is pretty expensive, and altering an object in a KD tree or a quad tree or something that we're going to be using later. As you can see, I've kind of screwed up the input and drawing systems a little bit. We'll pretty much spend the rest of the video fixing. Anyway, as I was saying, modifying an object in a KD tree or a quad tree is very expensive, and we're going to be using a KD or quad tree to do collision detection eventually. So we are replacing the current system with one that basically minimizes how many times an object is actually altered. If a missile hits a ship, then it is the missile's responsibility to say, I hit something, I explode, and the ship's responsibility to say, I got hit by something, I need to be damaged. The problem with this is that each object has to notice everything that happens to it all at once and deal with it instead of being able to do it incrementally. But the advantage is that each object only has to be changed once, so the KD tree doesn't have to be rebuilt multiple times. Now this might be a pain in the butt, but each object only gets altered once, it only alters itself, and so we only have to change it once. We only have to search through the list or tree to change it once. It also keeps things in sync, since if two objects hit a third object and they both affected it somehow, then what order the evaluation took place in might matter. For instance, if one destroys it outright and the other does a little bit of damage to it. When we're building though, evaluation happens all at once, so what order things occur in doesn't matter, which is good because it's also undefined. The list is in no set order, so there's no guarantee to there's no way to guarantee that things happen the same way in the same order every tick. In this new system, it won't matter. Anyway, that's what I'm doing, except right now I'm flailing around completely screwing up the input system, because the input system was the one point where I deliberately modified an object several times. If you pressed the left key, it would increase your rotational velocity a bit. If you pressed the forward key, it would accelerate you a little bit, and if you did both at once, it would do one and then do the other. This is no longer possible, so basically we have to change it to do both at once. I've just gone through and completely screwed up. Right now I'm modifying some of the library code that I have to account for this. Basically adding a capability to check whether or not a key is pressed, which I couldn't do before. Before, it was purely callback based, so I would give it a function and it would return a result. But that no longer works because it I have several functions returning several results, then an object is modified several times, and we can't handle that. So this may be a huge mistake, and limit me in ways that end up not being workable, but I think it'll work out. It'll just require a bit of clever coding, and not forgetting what I'm doing in the middle of what I'm doing, so I don't make something inconsistent. As you may have noticed a few times, sitting and staring at the screen and wondering what the heck is going on is an important part of the debugging process. So is printing out random error messages as certain parts of the game happen, so that you can make sure that they are happening when you expect them to.